So this section of the Xi book actually goes through a few important issues relating to finite state machines, some of which we've already talked about. I'm not going to go over every single piece of information that is currently in the Xi book, but there is one very important issue that the Xi book discusses that I would like to touch upon in this video. So if we take a look at a finite state machine like this one that we've been using over the course of these videos that represents our fair arbiter, you'll notice that for each state, there is only one possible path out of that state for each particular input. And what I mean by that is this. I have 2 bits of input coming in to this particular finite state machine. That means there are 4 possible combinations of input, right? And so for each state, there should be only one path for each of those 4 inputs. Only one path out of this state for each of those 4 inputs. So if I see 0, 0, right? 0, 0 will only take me down this transition. None of the other transitions will work for 0, 0, right? I can do the same thing for every other state, right? In this state, there's only one path that will lead me out of this state on the input 0, 0. That's this transition here, right? No other path out of this state will work if my inputs are 0, 0. So if we have a finite state machine defined in this way, we can actually say that it is deterministic. Every single finite state machine that we take a look at in this class is going to be a deterministic finite state machine. There will only be one path out of every state for a particular input. Consider what would happen if that were not the case. Consider what would happen, for example, if this transition also was active on 0, 0. Then I would have a choice to make, right? I would have to decide whether I'm going to take this transition or this transition when I see 0, 0. Ultimately, I could potentially try to take both, right? So then I have 2 paths, or I have 2 alternate universes, if you will. But then I might have another choice for the next transition, and another choice for the transition after that. And so the paths start branching out very rapidly, and it becomes difficult to tell what the ultimate result should be. Which of those alternate universes should I take? In other classes, you might find out a solution to that particular problem, but for this class, we're going to keep it simple and make sure that everything is deterministic. What makes this a little bit complicated are when we have these don't care values for our inputs. So in this particular case, I see 1x on this transition, which means I don't care what this second bit is. This second bit could be a 0, or it could be a 1. It does not matter to me at all, right? So this transition actually is consuming 2 of the possible 4 inputs that exists for every single state. So 0, 0 is this transition, right? 0, 1 is this transition here. 1, 0 is this transition, but 1, 1 is also this transition. So I can trace all 4 possible inputs, right, from this particular state. You should be able to do the same thing for each of the other states that are in this particular diagram. What that means is that when I see a don't care bit, when I see an X that represents I don't care what the value of this bit is, I know for a fact that this transition is going to have multiple possible inputs that could lead in this transition being taken. So if you want an exercise, if you want to check your understanding of this particular concept, revisit the garage door example that we saw in a previous video and see if you can convince yourself that this is a deterministic finite state machine and there are no paths that could possibly be, there are no choices that you have to make in any of these particular states. There are no inputs that are duplicated from any particular state. Take a few minutes and see if you can convince yourself that that is in fact true.